imagine that you have a leaky pipe under the kitchen sink. To catch the water, you place a coffee can under the leak. Determine the sum of the absolute values of the residuals for each model. So if you notice, we have two tables. We have our first equation here, second equation here. Same time, same mass. Fill in the tables to help you find the residuals. So how do we start off finding the predicted value?
Don't you do the x equals something, mx plus b?
5 times 30 equals 60.
Correct. We're going to substitute in the time. Time goes on which axis?
X.
And the mass goes on y. So we are going to substitute in the time to this equation to get a predicted value. So we have 30 times 5 plus 16. What does that give us?
166. Wait, where did you get 30 from?
This equation right here.
Oh.
$30 times 10 plus 16.
316.
30 times 15 plus 16.
466.
30 times 20 plus 16.
616.
And 30 times 25 plus 16.
766.
How do we find the residual?
G.
What are we going to subtract?
G minus G.
G minus G?
G.
Mass
Which
minus
G?
predicted value.
Okay, this is our actual mass right here. Remember yesterday we looked at finding the residual. We've been talking about it. It's the actual minus the predicted. So 160 minus 166 is, and what's the absolute value?
6. How come one of mine was one of those?
350 minus 316. 34. You know why that is? Because when we plot the line, some points are above, bless you, and some points are below, Connor. So the difference is going to be negative sometimes and positive other times. 470 minus 466 is?
54. Wait, what?
470 minus 466.
Yeah, 4.
Oh.
Absolute value.
4.
570 minus 616.
Negative something. Negative 46.
Absolute value.
46.
790 minus 766.
24.
How do we find the sum of the absolute value of residuals?
You add them all together.
And
You
what do we
get 114. Wait, 114.
Okay. Everybody agree?
Yep.
Okay. Same data, different equation. So what am I going to do with this?
33 times 5 plus 15.
Very good. 33 times 5 plus 15 gives us 33 times 10 plus 15.
345.
Mm-hmm. 33 times 15 plus 15. 510.
Yeah.
33 times 20 plus 15.
675.
And 33 times 25 plus 15.
840.
Okay. How do I find the residual?
Subtract the mass by predicted value.
All right. So 160 minus 180,
Negative 20.
which gives me an absolute value of
20.
350 minus 345.
5.
Absolute value
5.
470 minus 510.
Negative 40.
Absolute value
40.
570 minus
Negative
675. What is it?
Negative 105.
Absolute value.
105.
And 790 minus 840.
Negative 50.
Absolute value.
50.
What's the sum? Okay. Which of the above equations more closely approximates the data?
First,
Why?
because the numbers are closer.
Numbers are closer.
Wait, wouldn't it be the absolute value, like the sum of the absolute value of residuals is smaller?
Yes.
Okay.
Your numbers are closer, gives you a smaller sum of your absolute values of residuals. So which one are you going to choose?
The first one.
All right, g of x equals 30x plus 16 because
Because the sum of the absolute value of residuals is smaller.
very nice.
I sound so
Because it's
intelligent.
of absolute value of residuals is smaller. Good.
Actually understood what we were doing.
You just brilliant.
I am
The
the
table below shows the volume of water flowing from a garden hose over time. Draw a scatter plot. So what are we going to put on the x-axis?
The time.
The time. Okay, time is x. What are we putting on the y?
Value.
Volume. So time, volume.
Scatter plots make me upset. So I always do that.
I'm with you, Lauren.
We need to go up to what on time?
6.
Okay.
Lauren.
What? I'm sorry.
What do we need to go up to for volume?
94.
So increments of what?
10.
You guys want to do 10 or you want to do something else?
7.
Do 10,
Seven.
they're close.
That's good.
Or you can, I'm feeling 7 or 5.
Could you do, no,
Can
I'm
you do
feeling
5?
10, 'cause I don't think you could do 5.
0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50,
You
55,
could do
60.
20s.
What's
65,
With 10,
70,
you can skip a line in
75,
between.
80, 85, 90. We can do 5s.
Alright, let's do 5.
I'm not doing
Am I allowed to?
Wait, who?
You can do it however you want, Kenna.
Fine.
Fine.
I will then.
Don't be so sassy.
Yeah.
Lauren, you've known this all.
Yeah.
I know.
That's coming out of your mouth.
It is. There was an explosion, no big deal.
All right, so now start plotting your points.
Scatter plot.
And they hate you too.
0, 0. That one's pretty simple.
Do them all wrong.
Over
Yeah,
1,
zero,
up
zero,
15. Over 2, up 29. Over 3, up 48.
I done.
Wait, what was I doing? Oh god.
And draw a line that closely approximates the data.
No. No.
And you were just calling somebody sassy.
Going on strike
Okay.
tomorrow. I'm going on strike in gym class because I refuse to.
I'm going on strike in health. I just got out of gym class and it's basically like gym class. So annoying.
Wait, do you have Kittle?
No, I have marriage.
All right,
and
girls.
BC.
Write an equation for the line in the form y equals mx plus b. So what are the two things that we need to write an equation?
The slope
The
and
slope
the
and the
y-intercept.
y-intercept.
The y-intercept is 0, just in case you're wondering.
I was.
Yeah, it's y. Or 0.
How do we find the slope?
Change the y. Change that.
All right. So what's my change in y?
6. Or 94.
94.
94 over 1.
94 over 6.
Wait, why am I doing? Oh, just kidding.
So 94 divided by 6 gives us
235.6.
no.
15.6
It says 9.935. 15.7.
If you weren't able to easily determine your y-intercept, what could you use to help you write the equation?
You couldn't find your y.
y minus y1 equals m. X minus x1 equals
What's your y1 value?
0.
And she did.
This is a cool word. Get over it, bro.
What's your x1 value?
0. So it's pointless because you're just multiplying by 0.
Right. We knew that our y-intercept was equal to 0. So our equation is what?
Y equals 15.7x plus 0.
Very nice. How do we find the residual?
You subtract the predicted from the value.
We didn't find the predicted.
We didn't find the predicted.
So we insert our equation into the fancy thing up there.
Okay.
Fancy dancy.
So
it'd be 15.7 times 0 plus 0. So
Equals?
it's 0.
okay. 15.7 times
15 plus
1 is
15.7.
Oh, just kidding.
15.7. 15.7 times 2.
Is 31.4.
15.7 times 3.
47.1. Hannah, are you sure your calculator's working right?
I just said it wrong.
15.7 times 4.
62.8.
15.7 times 5.
78.5.
And
94.2. All you have to do is add 15.7 each one.
you're correct.
You are a genius.
I know, thanks for
Let's say
noticing.
94.2. All right, so can I find the residual now?
See. Oh, but we can now.
How?
You subtract the time from the predicted.
Today's Tuesday, right?
Subtract the time from the predicted. Everybody agree?
Or would it be?
Go with the
No, it would be
volume
volume.
predicted.
Remember, this is our actual volume. This is our actual volume. This is our predicted volume. So we're going to find the difference in those.
Alrighty, now.
0 minus 0.
Is 5.
0.
What's the absolute value?
0.
15 minus 15.7.
Negative 0.7, and the absolute value is 0.7.
29 minus 31.4.
Negative 5.4.
2.4.
2.4.
Absolute value?
2.4.
48 minus 47.1.
0.9.
Absolute value?
0.9.
65 minus 62.8.
2.2.
Absolute value?
2.2.
73 minus 78.5.
Negative 5.5.
Absolute value?
5.5.
94 minus 94.2.
Negative 0.2.
Absolute value.
We're slowly turning us into robots now.
So we have the residual, absolute value of the residual. Predict the volume of the water flow after 15 minutes. How do I find that?
15 times.
Wait, you add what? All the predict or the
Absolute value.
all the other.
Isn't it 15.7 times 15?
Or would you
It
do
says predict
y
the volume.
equals 15.7 times 15 plus 0?
I was just going to say that.
So why am I not adding the absolute values?
Teachers and students, please excuse the announcement. Freshman and JV boys basketball are excused for today. Pardon me. Thank you.
Good luck, Mason.
Bye, Mason.
I love you.
Mason, just hold up a minute. I'll give you your work. All right. So why are we not adding the absolute values?
It doesn't matter.
It doesn't ask us to. It asks us to predict the volume of the water flow after 15 minutes. Time.
Ooh, I choose 5.5.
And what units are these?
Liters.
Liters.
Wait, wouldn't it be liters cubed?
Nope, liters are not cubed.
That was